Well, first of all, thanks to everyone who has the time to come and listen to us talk about this roundtable. I'm going to set some ground rules, really, just to let you know that this is totally unscripted. There's no outline. It's just a few of us guys talking about electric vehicles and some projects that we were involved in. That actually, the videos from those really prompted uh, a point that I've had a concern about, and as well as Bud and Dirk. And before we get into that and actually look at those videos, I'd like to introduce Bud Center. Bud is the um, Director of Technical Products and Curriculum. I should get that title right, but Bud, I'm glad you're here tonight.
Thanks, Jeff. Just a little bit about myself, I guess. I've been in the automotive industry approximately 38 years. Spent the majority of my career in the collision repair industry, and spent some time as a technician initially. Then moved into shop management, and ultimately to MSO leadership in a senior leadership role with the MSOs. And then went and spent some time as a material damage manager on the insurance side of the industry. And then iCar came knocking, and I joined the iCar team here in Appleton about 4.5 years ago.
Yeah, and I'm glad you're with iCar too. And one of the big roles that Bud has is he oversees all of the curriculum and the subject matter experts, video, graphics, and it's an important role, and it's got a lot of moving parts, right?
There's a lot going on. No complaints. We've got a lot going on. A lot of great people up here, and we have some big plans for 2021, and working on the ADAS and EV of the future. So
absolutely, we absolutely have some huge plans, and so a part of those big plans is Dirk Fuchs, who we brought on board, and Dirk's role is actually the Director of Technical Programs and Services. I think I got that right, Dirk? So tell us a little bit about yourself. You play an important role in the future of our organization.
So yes, you did. You said it right, Jeff. And when Bud was saying like he is like 25 years in the collision industry, I started calculating, and it took me until now that I realized I'm since 19 years in the automotive industry. So my background started actually in an apprenticeship program in Germany, and then I made my way up over an factory instructor for Volkswagen to an automotive manufacturer, what sent me over here to the United States, and I helped them to build a technical training team here in North America. I fell in love. I have twins. I'm stranded in North America, and I have to make it work. So that's always what I say. No, I definitely enjoy being here in this beautiful country, and I think I found my new love for the collision industry. And I'm now since 4 months on board at the iCar team. And what I'm bringing to the table is a little bit more on the regular repair industry knowledge, means everything around ADAS, EV technology, and especially the EV, what we want to talk today. That's where I felt in love. And I developed a couple of training classes for different manufacturers and other stuff. And I'm hoping I can support iCar here in the development towards those new technologies.
And Dirk, we appreciate the background you have from Europe, and we know that in Germany and in Europe in general, that the electric vehicle is certainly more popular than it has been here in the U.S. so far, and for a lot of different reasons. But you certainly fit into our team, and has been an asset in a very quick way. I know myself, I started same way, started out working full time in the industry in 1981. That was a long time ago. But, I started out working on cars, and it's such a great industry. It's full of opportunity. I hate to hear people talking negatively about our industry, because it is. And probably what I think it still excites me after 40 years is all of these changes, right? That what can easily be seen as expensive challenges also is revolutionizing our industry, and it's changing, and it's anything but boring. And I think that's really, it's about the attitude that you have. And I appreciate you two guys and what you bring to the table. And iCar's role, which is really important, is to work with the car manufacturers, understand the technology, create the training programs and information for the collision repairers, so that the collision repairers are prepared to work on the cars. And electric vehicles, a little bit different in a lot of different ways, and you guys can talk about that. But I know when we've sat around and talked, we've shared a concern around the dangers that a technician or even an estimator may face when an electric vehicle comes in, or really anyone in the shop who would just out of just being complacent and not really making the distinction between an electric vehicle and an internal combustion engine car. It could be dangerous. And this first video, I think, is really probably one of the most important things that a shop and a technician can get their heads around right off. So you guys have any comments about this first video before we get started? It was pretty impactful to me.
Yeah, well, the first video really talks about personal protection equipment, PPE, and goes through the different things that you need to consider when working on these high voltage vehicles. There are so many things that people understand it with the amount of time that even hybrids have been around, that, hey, don't touch the orange cable. Mm-hmm. Most people understand that, but really understanding all of the safety requirements. What type of gloves do you need? Some manufacturers recommend the face shield and even a bodysuit. Mm-hmm. When you're working on these things. So the first video really walks you through some of the things you need to consider on the PPE side of the repairing high voltage vehicles.
Everybody's going to see also Dirk, who's one of the individuals in this video. I love your glove toss there too. So that's a highlight, one of the highlights. Dirk, you have anything to add before we show this video?
Let's dive in that video, and I will add my comments afterwards.
Okay, let's do that. All right, so let's roll the video.
I want to disconnect that vehicle desperately. I can't wait doing it, and I love to be involved in those high voltage technology, and this is a high voltage vehicle. Nissan Leaf. My first time actually I worked on a Nissan Leaf, and that was it's really exciting for me, and that's the reason. Jeff, let's do it, huh?
So before we get too much further along here, just a couple things really quick. The charging port. And again, this is kind of a common sense thing, but it's very important to understand that anytime we're going to be working on one of these vehicles, this probably shouldn't be plugged in all the time.
Shouldn't be, yeah. It's a really important point. I want to point that out a little bit more than the contacts in the battery. Usually when we have a normal situation, we bring the vehicle, we drive to the city, we park it in a parking garage, and there is a charging point. What you're doing, you park your car there, you plug that vehicle in, you lock your car, and you go away. Usually when you unplug your car and you stop the ignition and stop your car from running, what is going on in the car, our contacts in the batteries open up, and the battery is not live, the system is not live. But when we're plugging this guy here in, we want to charge the battery, that means we have to close the contacts, and this is the case. Always when our charger cable is connected, our contacts will be closed, and this is dangerous for us working on a vehicle. That means, I understand we want to have a full charged battery, what is good for the customer later, and so on and so on. But we're working on the vehicle, we're working on a high voltage system. First rule, unplug this cable, please. Have that memorized, and this is really forgotten really quick.
Okay, so the next thing we want to touch on just really quick is high voltage safety gear, personal protective equipment. Now this particular vehicle, we've already pre-scanned it, and we've verified there are no high voltage faults in the vehicle. There are some faults in other systems on the vehicle, but right now, so far as the high voltage system, we have high confidence in the overall electrical integrity of the system. But we're going to transition over here to our gloves just really quick. Mm-hmm. And we've got some nice welding gloves over there next to you, Dirk. Okay. And they're great for welding, working with hot stuff and sparks and things like that, but they are absolutely not high voltage safety gloves.
So what I'm doing with them now?
Yeah, you can put those aside. We also have some nitrile gloves, some green ones and some black ones, and there's blue ones we don't have sitting there, but lots of different colors. They too are not high voltage safety gloves. They're great for working with chemicals and other things, so we absolutely don't want to trust our lives to those.
So what are those?
So here we've got some lineman's gloves. So here are the rubber lineman's gloves that we would typically be using whenever we're working with, or there's a suspected high voltage exposure risk. And so it becomes an additional safety redundancy for you personally, that if there is some unknown fault or compromise, this is your last line of defense if there are other issues in a vehicle. Now again, with this vehicle, we've got pretty high confidence that there aren't going to be any issues, and we'll kind of proceed forward. We also have the leather protectors, which are, of course, to be used over top of the lineman's gloves. Those leather protectors should not be used for any other type of work other than with those lineman's gloves, so that we don't end up with any metal splinters or anything like that. They are there to protect the lineman's gloves from getting punctured or damaged whenever you're doing work.
When you watch that video and the whole concept of these gloves and the gloves on top and everything and how important that is, you know, for many years ago, I was a refinish technician, and there was always this kind of feeling, maybe it was just one I had, but I know a lot of the refinish techs around me felt the same way, that a lot of the personal protection equipment that we were supposed to wear just felt cumbersome. We didn't always wear it like we were supposed to, unfortunately. And I don't think that that's a really good idea. And Dirk, I know you and Jeff Poole in that video made some really good points, but I know you have some things to add now.
Yeah. You know, you said you appreciate that I'm coming from Europe, and in Europe, you know, we have all those regulations and other stuff in place. And interesting is for me always when I see regulations what manufacturers giving out, and certainly we're following these regulations, then I think they are really, really important. But protective gear, like we showed with the gloves and other, you know, when I'm verifying zero potential and I make sure the vehicle is disconnected, technically I would not need them, but of course safety first, and safety is everything. And you are always stating you are worried that the first technicians maybe get hurt, and that's what we don't want. So to that personal protective gear to say is for me really important. No, I want to say something else actually. What is for me, as a guy out of the regular repair industry, completely different. You know, regular repair industry, they're going to a running vehicle where everything has no problems, and you disconnect that vehicle out of a service reason. This is a completely different story as I'm running in a vehicle what just came out of an accident. And that's where this protective gear is so important. And I have no idea about the state of the battery. I have no idea what maybe is there an open lead from an orange cable, as you just stated, to the chassis or other stuff. I really admire those guys who getting out of the highway, putting those car on the flatbed and bringing them to the next repair shop. I personally, before I would touch a vehicle there and put my hook on and pull it off, I would have my 2-pole voltmeter and would check is there any potential of the chassis. That's a little bit the fear what I have, and I think this is our big goal to educating the whole industry, not only the collision person, also people who bringing vehicles into the shop, driving those flatbeds and other stuff, other persons or other people. That everybody should know about it.
Yeah, that's a really good point. I know you've stressed that so many times, and just keep stressing it, because we have a long ways to go in our industry around the safety of that. Bud, do you have anything to add to that at all?
You know, it's interesting. Dirk talks about some of the safety, and just helping everybody understand just how serious this stuff is. I was having a conversation with my son about electric vehicles, high voltage, and he comes out of an industry that he's been working with high voltage. And I said, when you started working on this stuff, what did they give you for training? And he said the shop foreman handed him the RO to go out and work on the truck. He was in the heavy truck industry, and said, "Don't get dead." That was it. That was the extent of his high voltage training. So you think about what could have happened it's critical that everybody really understands the importance of the safety when you're working on these vehicles, understanding how to disable these vehicles and confirm that they're zero potential, and making sure they're safe before they start working on the vehicle.
Yeah, that's a really good point. So let's just let me just a couple of things. I did say it was off script, and it really is, but just in the last, I don't know, week or so, just some of the announcements, and one of them really stuck out to me, and that was 14 years ago, General Motors introduced the Volt electric vehicle. And 14 years from now, GM hopes to sell nothing but electric vehicles, which is 2035, and be completely carbon neutral by 2040. And that's pretty important. You stop and think about that. And then I know even just recently, I think it was today or yesterday, that Toyota is to introduce 2 battery electric vehicles and 1 plug-in hybrid this year, with sales in the U.S. in the summer of 2020, which obviously just next year. Then you've got Mercedes, who's talking about 5 battery electric vehicles in the U.S. by next summer. And then one of the really cool ones I jumped on was that Audi with the e-tron GT, the 150 mile an hour battery electric vehicle, is going to be in the U.S. for sale this summer. It's really cool. The whole idea of an electric vehicle, besides it just being tremendous technology changes, it's actually pretty cool, right? So
Jeff,
Yeah.
Jeff, you pointed out all those great manufacturers with their great technology and everything what comes. This is amazing vehicles, but I have to say one thing.
Mhm.
General Motors got the Dirk Fuchs Award for the best Super Bowl commercial in this year. So I don't know who saw that, but check out on YouTube or wherever you can see it, General Motors commercial about electric vehicle at the
Yeah,
Super Bowl. Awesome. I love that.
it's real.
Yep.
Yeah. So
Yep.
all right, let's talk about the second video, the one where Dirk, you and Jeff Poole are actually inside the vehicle. And the thing that really jumped out to me is that you talked about the gloves, and now you guys are in the vehicle, and Jeff actually has the gloves on working. So any comments before we roll the video?
So when you see that, yeah, go ahead, Bud. Sorry.
No, I know it's in your contract to be able to talk a lot, so go ahead.
So no, what I think when we did that, and I remember it really well, and you have those gloves and you are inside the vehicle and you want to pull the battery service disconnect. There you see that it's not that easy to really wear this protective gear and work. It's a challenge, and it's not that easy to really do it. And you think in that moment, let's take those gloves away. No, don't do it. Fight through it. Leave those gloves on and do it. Don't take the easy way. And I'm thinking when we did it, like, okay, let's we are safe. So like that's that thought process. And I think a lot of technicians will have that feeling or that idea. I can't touch it really with these gloves and so on.
Yeah, it lacks the feel. It lacks the feel.
Yeah.
It lacks the feel. Go through it. You have to for your own protection. Sorry,
So
Bob.
I think what stood out for me in this video is making sure that you have the OEM procedures available before you start pulling the service disconnect. Not just read them before you go out there, but actually have them with you in the vehicle. So if you're having difficulty getting that disconnect out, you can look at it again and understand all the interlocks and things in them that you have to disengage before you can get that disconnect out.
Oh, that's a really good point. I'm glad you brought that up. That's so let's go ahead and without anything else said, let's roll that second video.
We've already looked at the Nissan procedures on shutting this vehicle down. And in the procedures for this particular vehicle, step one is the key is turned off, the ignition's turned off, and the key is, as Nissan's procedure describes it, on your person as the technician. We prefer to take and put that key in a lockbox on the other side of the shop, and it is currently in a lockbox on the other side of the shop. So we do have that key secured very, very well. And the next step in that procedure is to take and disconnect that 12-volt battery. Now we have both terminals disconnected. The procedure calls for the negative terminal only. I like to take that extra step of safety precaution and take and disconnect both cables. Ultimately, we've got those taped off so that they can't migrate back over and accidentally make contact again. Dirk, why the extra precaution of disconnecting the 12-volt battery? You already told me the contactors opened up when we shut the ignition off.
Contact is definitely one point. Another point is all the control units on this vehicle running still on 12 volt. CAN bus, communication, everything is 12 volt. So it means we're taking off the 12 volt battery or disconnecting the 12 volt battery, my control units are shutting down. That means there's no communication anymore possible, and in this case we open the contacts in the battery. So theoretically we already did two things to disconnect or shut down the high voltage procedure. We removed the key, ignition shut off, means the contacts in the battery will open up, 12 volt battery, contacts will open up. So this vehicle has a battery disconnect. That's what we learned. And the battery disconnect is actually in the car. And that would be then my third step for a disconnecting procedure. As a lot of people know me, a lot of people hear it on my weird accent, I'm German, and we Germans are crazy with regulations and other stuff. And in Europe is really a regulation in place. What defines those disconnecting procedures? Here in the United States, you are typical American to me. No, I'm kidding. It's no regulation in place.
It's
that
different.
means we have to follow 100% the manufacturer guidelines. And the manufacturer guidelines here, that's what we're just doing. Key out, battery disconnect, but 12 volt disconnecting, and then high voltage battery
Now,
disconnect.
before we go back to the interior of the vehicle and look at that high voltage disconnect, I want to speak generically, step away from the Nissan just for a second, and think about other vehicle makers. You know, they may have you actually in that high voltage shutdown procedure before you disconnect that 12 volt battery. They may have you do certain things and then use a scan tool to verify the contactors are open and that there's no issues or faults or anything like that before you go to that additional step. Or in some cases they don't even have a high voltage battery disconnect. You know, it's reliant upon the contactors opening and the verification with the scan tool or whatever other measures they have in place.
Let's talk a little bit about this battery disconnect versus service disconnect. And I want to show that, and I would say let's go inside and discuss that a little bit inside the car when we're disconnecting the battery, and we will go over there and check this out.
All right.
So now we are in the passenger cabin here on the back side, and the disconnecting, battery disconnect is exactly under this when we're reading the Nissan descriptions.
Absolutely.
You have them with you.
So I have the procedure here, and as we take a look at this, it requires just removing this cover. And then there's also a metal cover underneath, which has 3 bolts. We've already removed those, and we remove that. Now, I like having a procedure if I'm not really familiar with these service disconnects to make sure I understand how the interlocks work on those connectors, because typically whenever you come down in here, you don't want to be going down in with screwdrivers and things like that. You risk damage in the disconnect. So as I've already read through the procedure, it leads me to take and pull up part way. Then there's an additional tab right here that I have to then exert force backwards on to continue lifting the lever around, and that takes and removes the service disconnect.
Wow, you did a good job with the gloves.
Actually worked out pretty well. Now, the procedure actually guides you to take and put some sort of insulating tape over top of that service disconnect location, and we'll do that so that we can keep any debris from going down in there, and hopefully alert folks, they shouldn't be tampering with that in any way, shape, or fashion. This service disconnect we'll take and we'll secure in a location, probably in the lockbox with the keys.
Can I get it? Can I check it out?
What's kind of interesting about that is I see the 2 big terminals, and I understand that those 2 big terminals break the connection somewhere in the cell series circuit. But I also notice there's 2 smaller connections in there. Can you tell me what those 2 smaller terminals do?
Interlock. We call it interlock. And the interlock is through every component or every plug in the whole high voltage system is always an interlock. 2 small, maybe I hold it here under the camera, you can see here in the middle those 2 little pins. That means Jeff removed that that plug here, or that battery disconnect, now we interrupt the circuit of the interlock. In this moment, yeah, we have another information for the control unit. Hey, somebody pulled something out. Then it's not only in the battery disconnect, as I said, it's in every connection, high voltage connector in the whole vehicle. So this is a safety, a really, really important safety measurement or feature in my opinion. Then when somebody has no clue, the system is live, he would pull a cable, this interlock will open and we open the connectors in the battery to shut down the systems in regards to safety.
Now, what about the systems that don't have this type of a service disconnect? What happens then?
Good. Now we are on the point. Battery disconnect, service disconnect. So maybe I hold it a little better. I hold it under our second camera as well.
So this one doesn't have an appearance of being on the high voltage circuit at all.
Exactly. This is a 12-volt system, as well as this little cable, this interlock here. This is, you can compare it with an interlock. Then when we pulling this guy here out, we will disconnect this interlock, and then the batteries connectors will open up and our system is disconnected.
On the side here, the little hole, what's that typically used for?
The little hole, good that you said it. I brought a little padlock here with us, and I put that padlock in this little hole, and this is a really important thing for those systems. Then you were saying this guy you're putting in the
lockbox.
In the lockbox. That means this guy is gone, nobody can take it.
And I'm the only one that has access to the lockbox.
Yeah. In this case here, you lock that and you take the key and put it in the lockbox. That nobody can switch.
Now, typically on a real vehicle, this would have wires coming out the other end of this connector that tied in with the wiring harness for the control circuits for
this is an example from a BMW. This is a BMW service disconnect. What is usually an i3 has it in the front, in the motor hood area, front left, or the 3 Series BMW has it where the battery is located on the back right side. It's somewhere located, and yeah, what is the procedure here is you put your ignition, you switch off your ignition, you disconnect your 12-volt battery, and you were saying then would be a good idea. You were saying before we had this discussion a little bit. Can you remember? You were saying, maybe I disconnect the 12-volt battery later. I will do the same when I have a service disconnect. Then I want to see if I get a message in the on my control, on my dashboard, information display. Thank you. That means I would disconnect or pull the service disconnect, switch on ignition, and then you get in the display a message: service disconnect pulled, the high voltage system deactivated, some message you get. And that would give me as a technician already a good feeling I'm on the right track to disconnect the system.
Or perhaps there's a verification on a scan tool or something like that.
Yeah, you can verify on the scan tool, you have it on the dashboard. The next step is then, of course, switch off ignition, lock the key away, disconnect your 12-volt battery, and then verify zero potential. Zero potential means verify the system is not live anymore.
So I've noticed in some cases, some vehicle makers will actually have dummy plugs that go in some of the connector locations that better seal and secure those locations. And with the low voltage disconnect, I've also noticed sometimes, I want to say under the hood, up front in many cases, they'll have like the first responder cut loop, but it's actually on a connector. And for the first responders, as I understand it, the cut loop is there. That's the quickest way, I want to say, to cut that 12-volt circuit. Versus for us in service, the procedure might be to just take and disconnect that connector and not run the cut loop per se.
Yeah, that cut loop for first responders, really important. By the way, you can find rescue sheets And every manufacturer produced those rescue sheets where you can see where is the cut loop. So when any first responders here on that show download them, you can really Google them easily, put the manufacturer in, put the vehicle in, Nissan Leaf, rescue sheet, put it on Google, and you will get it pretty quick. And you can download that, and then you all know where is the battery located, where is the battery disconnect, where is that loop, for example.
So for us service technicians, though, it's important that we are accessing the service procedures, because they will go into more detail about some of the additional steps that are necessary to verify voltage is shut down, and we're going to take a look at some of that here very shortly.
Yeah.
Okay, so you know, as we start to look at the third video, this next video is Dirk, you and Jeff are actually under a vehicle, and I think there was a lot of things to note, but I will let you guys. Bud, anything jump out at you initially about the video with these guys under the car?
Well, I think there's really a few things for me, right? I think most people that look at the service disconnect procedure, they think, okay, I'm done. I disconnected the vehicle, and the vehicle maker says, well, let's just wait, 10 minutes, and then we're ready to go. Well, what about that extra piece, and in the video, we'll see it, verifying zero potential and all the different tests that you do to confirm zero potential. Again, what Dirk talked about earlier, in the fact that these are vehicles that are coming in after a collision. So while in the service world, and you're dealing with a new vehicle, pulling the service disconnect and waiting 10 minutes might be enough. Mm-hmm. But in the collision environment, and not understanding what's happened to that vehicle and where there could potentially be something that's rubbed through or shorted, or you don't know, it's critical to verify that zero potential.
Oh, that's a really good point. Dirk, any final words of wisdom before we show this video?
I have to smile that I remember in this video I say one thing, trust me and not a manufacturer or something like that. And Bud told me afterwards, Jake, you can't say that as Icon. And he's right. We always following the manufacturer. In this video, I was referring really to the diagnostic tools. And it's not so much common in North America to use a 2-pole voltmeter. And I will explain in the video why a 2-pole voltmeter is the best tool to do it instead of a multimeter, what we all technically would use to verify how much voltage is on that system. So we don't want to know how much voltage is on the system. We want to know only one thing. The system is disconnected. Yeah. And that's the reason I made that comment. I know for my future, I will never say that again. But
well, that's a really good point. And I know we've all shared our concern too around complacency at the shop level. If they're not pulling the repair procedures from the car manufacturers, not following those, we have no tolerance here when it comes to the dangers or lack of safety or whatever. I mean, we just want to be careful. So good, that's a great comment. So I'd say let's go ahead and get that video going. I think it's really an interesting one.
All right, so we've disconnected the battery safety disconnect up in the interior, and the last step in that procedure actually asks us to wait for 10 minutes, minimum of 10 minutes, after pulling that before we proceed with any other operations. Why do we have to do that, Dirk?
Good question. The 10 minutes are really important. Then we have an inverter, and an inverter is a rectifier, and working in rectifier you need capacitors. How you call them? I call them capacitors.
Sometimes they're referred to as condensers. That's an older term that sometimes you still see in some of the modern service information.
Okay, I never heard that word before, but my German, English, German is capacitor. So we have intermediate circuit capacitor in that in the inverter. What is a capacitor? It's like a storage. It's like an accumulator. It's like a battery. That means now the system feeds, and I think we have here a 400 volt system, feeds the capacitors with 400 volts. So now we know the battery is disconnected, but we don't know how long it takes that the capacitor is discharging. And this is really, that's really dangerous. When you're not doing it, we're unplugging here our cable, somebody touch it, we can get electrified and we can die. the capacitors discharging time is really a serious thing. When the manufacturer says 10 minutes, we have to follow those 10 minutes. There is an active and passive discharge, but this is another story. I don't want to go deep into active and passive discharge right now. Then an active discharge should be directly discharging it, but we are not sure that everything works. That's the reason passive discharging time is 10 minutes at Nissan, and that's
so
what
we just wait. We follow the
wait.
procedure. We wait, and then we have to
making-
continue with our verification.
Correct.
Okay.
Yeah. So
right.
now let's wait 10 minutes. How was your weekend?
That was great.
No,
Fabulous.
I'm kidding.
We've already waited
Okay.
the 10 minutes though. So the next step in our procedure is going to be for me to take and disconnect the connectors. Now, these connectors, one of them is the main harness connector coming out, which goes up to the motor drive unit and inverter converter unit, and the other one is to a PTC, a positive temperature coefficient heater unit. And in order to take and find the procedures to get these apart, because they have a series of interlocks on them to take and disengage the connectors, we actually have to take and look at the high voltage circuit verification procedure, but that hyperlinks out to a different procedure that gives me all of the steps and the interlock sequence in order for me to disengage these connectors. And it's kind of intricate. So it'll take me just a moment here to come up in here and disengage these connectors. So as I take and get the first safety latch to remove, the safety assurance connector to remove, and the other interlock to remove, and pull the connector back, I can, and sometimes you have to wiggle them just a little bit and work them just a little bit. And what's really important is that you've already cleaned away any dirt and debris and stuff like that from around the connector, and that the connector is dry. So we have the main harness connector disconnected. I'll just put it off to the side, and then I'll work on the PTC connector next. And that one's a little tricky for the safety assurance connector and the main release tab, and then that one comes off like that. And so now that we have those disconnected, the procedure actually guides us to use a DVOM or perhaps some sort of other tester, but their procedure shows a DVOM in order to take and measure voltage on each of these connectors. And we'll start with this connector first. And so I believe you have a couple test instruments there that we're going to take a look at. What do you have?
You were saying DVOM. I have one
digital
here.
voltometer. Yep, that's what I'm used to using.
I have another one here. It's this device. You ever seen this?
I have never used one of those before.
You know, this is my favorite, by the way. I love those devices. It's called a 2-pole voltmeter. So, okay, what is the difference between a multimeter and a 2-pole voltmeter? So Nissan says use this. I say I would like to use this. So we're following the manufacturer procedures, but in this case, maybe you trust me. Now the reason is why I like to do this. This is a voltmeter what measures only voltage. It's not depending on an external battery like this one. Here I need a battery to operate it. So when the battery, here's a battery inside for some additional features, but when the battery would not work and I measure a power source like the 400 volt battery, it would show me 400 volts. Another big thing on that device is that I don't have to do anything. I go and measure. I can't make any mistakes. Here I have to set voltage, what we're measuring, DC, AC?
DC volts.
DC volts, yeah, we are on the DC side. And yeah, and here, that's the easy way. That I would like to use this. Can we do that?
So I've used the multimeters for a long time and various different brands. I always make sure that if I'm using a multimeter, I'm using a good quality meter that I trust my life to at that point in time. And there's also a verification procedure, whether you're using a 2-pole tester or a DVOM, where we'll take a known good voltage source, and this is about a 14 volt nickel metal hydride battery stick that came out of a hybrid vehicle battery pack. And what he's going to do now is just test his 2-pole tester. And what's kind of neat about the 2-pole tester is, in order for that to work, he's got both of his hands on the insulated part. He's not getting up there on the metal probes. He's well away from those probe tips, and that keeps him working safely, even on a potentially live circuit. So it keeps him at a safe distance. And so he's now verifying
14 volts.
There is voltage there. And something else that's kind of neat about these 2-pole testers that he just taught me about very recently is that there's a button on each of the handles that he can take, and while he's measuring voltage, he can push those buttons, and that actually loads the circuit a little bit. So if there is any, I've heard the terms ghost voltage or just stray voltage still floating on the wires, that would just load the circuit slightly in order that it would dissipate any kind of charge that was there. It's not meant to discharge the high voltage capacitors or anything like that necessarily, but that gives us again a little more assurance of the reading that we're seeing. Now we're doing this test right now to verify the tester is working on a known good source.
Yep.
Now he's going to transition up here to the connector.
Let me say one other word.
Okay.
Multimeter, 2-pole voltmeter. This guy shows us 14 volts. It shows us not 14 volts, 0.5, 6, 7, 8, whatever. Right. And this is what we are not interested in. We want to verify that we are in a low voltage area, what is minimum below 60 volts.
So we're not looking for the accuracy.
We're
here.
not looking for the accuracy.
But generally that within a volt or two, or
we want to see that
it
shows us now 0, of course, and not 400. 400, hey, we have a problem.
Interesting that the procedure says you're supposed to be measuring for 5 volts or less at this connector, and I would expect to potentially see 0 volts as you go up here and test.
Okay, I hear
I'm
it.
not sure what the meter is reading because I can't see it, but I'll let you go
0
ahead.
volts. I hold it towards the camera that our colleagues can see it, but 0 volts, and we verify 0 volts. Now I verified high voltage plus to high voltage minus.
Okay.
Okay, this is also what the procedure shows us on the Nissan side. European standard, and you know I like to do that, is always high voltage plus towards high voltage minus, high voltage minus towards ground, and high voltage plus towards ground.
So you're seeing if there's any potential faults.
When we talk about a certified disconnecting procedure, what a lot of the European manufacturers following, they make you 3 measurements. That's the reason I'm on the safety side. I like to make 3 measurements. That means I go here and I'm looking for a nice ground point. Let's go here.
I like to say there's no overabundance of precaution when you're working with high voltage.
So it's not illuminating, nothing.
Okay.
That means in this case, let me go here. Here we have 0 volts. Now I'm on a contact. Good. Nothing is lighting up. Okay. I'm 100% sure there is no potential on this.
So the rest of the Nissan procedures has us verify on the PTC connector the same thing?
Yep.
Basically looking to see that there's 5 volts or less. Hopefully
there is 0 volts.
0 volts there.
Okay, and I do here the same thing. And I go on the high voltage plus side and high voltage minus side.
Now,
that's all good.
After you've done that, it's also a good practice to come back to your known good standard.
Thank you.
And
really
verify
good.
that our meter is still,
14
that nothing
volts.
went wrong. So we've got very high confidence that what we've read here is accurate and true, and that we don't have any issues.
Yep.
Now, I also realize that in Nissan's procedure, they don't have us measure at the battery.
Correct.
Some vehicle makers may have verification procedures where there's special test harnesses that plug in, or they actually have you come in with a DVOM or some sort of voltage tester and verify that there is no voltage at the outlet of the contactor.
Yeah. You know, I would do that every time that I measure both sides. For example, for an insulation test, what we most likely will perform, you check your insulation in both directions. You check the insulation towards the battery as well. So it means the potential that I go on this side is really high. That means I would always recommend measuring both sides when I open up and harness like this. Definitely. So tape it up.
I'll take and tape these off in order that they're protected. Keep fingers out of there, and then we'll transition back out from underneath of the vehicle and take a look at some things.
You know, Jeff, I'm pretty sure a lot of our people who watching this thinking, oh, maybe this is a little bit crazy what they're doing. 2-pole voltmeters, 3 times verification. Yes, it seems like a little bit crazy, but you know, we talk about 400 volts. The safety here is the most important thing. 400 volts, I make a mistake, I touch something, the potential I'm dead is to 99.9% happening.
Does your wife have good insurance on you?
Good question. I have to think about that. But I like my life, and that's the reason I do a little bit more steps as is maybe necessary to keep safe and stay safe. And that's
Absolutely.
a really important part here. Yep.
Okay,
Let's
very good.
put it down and make some other
good.
magic happen.
I'll follow you out.
Okay, let me grab my multimeter. We don't want to destroy that.
Okay, so we're back, and any thoughts about that video? Any last thoughts since we've run it and we got to see it?
Well, as much as I did immediately go over and tell Dirk, hey, you can't say that, I will have to defend you on one point. You know, with your dual pole voltmeter, it takes mistakes out of the equation.
Mm-hmm.
You know, that's the big thing. You can't set the meter wrong. You know, you can't, oops, I've got a dead battery in my meter and I didn't know it. You know, this is something that you use it, you touch those two spots and it's foolproof.
Yeah.
So I got to give you that.
Good. That's a really good point. Okay. All right. So let's just move on since we're on a roll. This next video, you guys are back out of the car, back, I think, in the front of the car. And any comments about this video?
This is one where I'm going to let Dirk really take off and shine, earn his money. We started talking about electrical bonding and the importance of that, and the fact that these vehicles are safe, right? They're, for the most part, they're very, very safe. And I'm going to let Dirk dive in and explain electrical bonding, because that's a big piece of this.
He really likes this, then he's a little.
He does. He loves it.
Okay, Dirk, go ahead.
You know, what I really liked on all those videos, what we did, we went in a short time in so much technology in EVs. What I think afterwards, I was really impressed with Jeff Poole and myself, like we covered a lot of ground in those short videos. And bonding is a really important thing. What a lot of people, bonding is your lifesaver. Let's say it on this way. Bonding is important, that the vehicle is capable to figure out, is there any insulation errors? That means a lead, we have an open lead or anything. And this is, that's what I'm worried. You know, I remember my time at Volkswagen as an instructor, a lot of the electronic faults were actually related to ground errors. The ground got over the years really bad, corroded, and then the electrical system produced some faults. And you changed control units and other things, and nobody was looking to a simple ground spot and clean them. Volkswagen then introduced cleaning tools for grounding spots and others. So now we're talking about 10, 15 years ago. Now we're introducing those electrical vehicles where bonding is so important for the safety of the high voltage system. Then we have an isolated system. And I'm really curious how that bonding reacts in 5 to 10 years, living here in Colorado where I live, where we have snow, salt on the streets and everything, and how that bonding really, really impacts. You should, when you change components, you should make sure always to verify the bonding. And this is a special measurement method, what we're using here, a milliohm meter on a 4-wire band measurement method. And that's really the cool part on EVs for me, that we now introducing completely new methods to diagnose things what we're not used to in our industry so far. So we have to step up and learn new methods, how to measure things and understand those electrical components.
Very good, very good. I know, Bud, I share your concern sometimes about Dirk and Jeff Poole's passion for all of this stuff. It's I'm glad somebody has it. I love the concept of electric cars and the performance of electric car, but the level that they're passionate is very deep. So why don't we just move on and let's play this next video? I think it speaks for itself.
I've heard a little bit about terminology around electric vehicles, and I want to understand electrical bonding a little bit better. And I notice on this vehicle there's a large cable going from the inverter drivetrain control unit, looks like over here on the top, over to the chassis of the vehicle, almost like a ground cable. And if the battery were connected, it would connect to the negative battery terminal. Now, I know this vehicle does not have a gasoline engine. There's no starter motor. So why does it still need this large, heavy cable that's going over there to that module? Help me understand that concept.
You know you open Pandora's box right now here? Huh?
Probably.
Probably. Okay, how I can make that short. Bonding is one of the most important things on electric vehicles. It's our lifesaver, when you want to say that on this way. You know, our high voltage system is completely isolated. High voltage plus, high voltage minus, isolated from the whole system. But when we have an insulation failure, for that maybe to measure, we need an insulation tester, but this is a different story. Insulation, an insulation failure would, that high voltage plus or minus, has a conductor towards the housing or towards anything of those components. So now you showed this really thick, nice bonding cable. What bonded every high voltage component with each other together over the chassis. That's what we're using as bonding. What is your body resistance? You have an idea?
Probably right now my outer skin resistance is pretty high because my skin's so dry, but internally it's relatively low.
We say like 1,000 ohm. That's like a typical body resistance when you would get a shock, comes into your hand and maybe goes through my body onto the ground where I'm standing on. That we talk about 1,000 ohm body resistance. What do you think is the resistance of this nice thick cable?
I would think that'd be extremely low.
Okay, where are we going now as electricity? We're going towards the lower resistance. That means would be on a housing 400 volts in regards to an insulation error, and I would touch it. This would save my life. It would not save my life when I touch a second insulation error component. So this is a first error redundant safety precaution, can I say that? A second failure, that would be a problem. There is no safety.
So potentially if there were a fault within a module,
let's
where
say
high voltage
housing
would then come to the housing, it would essentially electrify the chassis of the vehicle to that potential relative to the other pole of the high voltage battery, which is still isolated.
Yep.
And it would take me getting between that and that other pole to get electrocuted. Within that, there's a lot of complex concepts that go along with it. And I'll tell you, we put a lot of effort into our Understanding High Voltage Safety course.
Yep.
And we go into a lot of detail about this concept and map it out pretty methodically so folks can understand it more granularly. I know it's an extremely important concept. It is a safety redundancy in the background, and it's something that some vehicle makers call out more importance on, and others maybe not as much. But even on hybrid vehicles, it's a consideration where you have high voltage systems.
And don't forget the insulation guard. Every high voltage system is equipped with an insulation guard. That means what we want to check on a constant base, how is the insulation? Are we still protected?
So when you say guard, it's being monitored.
It's a monitor. Insulation monitor would be a good wording as well. That means this insulation monitor checks always the component housing if there is any high voltage leak detecting. So now you have to think, this big cable, what you just pointed out, is completely oxidated. It's maybe has no contact, broke down. It's a really, it's defect. So now we have no loop between the ground, the insulation monitor, and our high voltage system. It will not detect anything. And it's okay, then we don't want to detect anything. But the cable is bad, and maybe we have an insulation fault on the housing, and the system can't detect it and can't produce a fault code. So that's the reason why it's so important that the bonding is good. And that's the reason that a lot of manufacturers, as you said, they always check the bonding of the components. When we're changing an inverter and high voltage heater, whatever, every high voltage component, and we change a component, it's always important that we make sure that the bonding is good after we bolt the new components to the chassis, or we have a wire or cable like this, that this is really okay. And for that we need a milliohm meter.
So I can't just use my traditional DVOM. I have a lot of faith in my traditional DVOM. I like it a lot, and I've done a lot of resistance measurements.
I have here a brand new Fluke one. It's, I think, a great multimeter, but we can't measure milliohm in this scale. What we could do, for example, with a specified milliohm meter. And what we're doing with this milliohm meter is we measure on a method, what is called a 4-wire measurement method. So we have now 4 wires. One is applying a current, a measurement current. And 1 amp is a good measurement current. So what we could do is, we don't need a fancy milliohm meter like what we have here. Let me switch it on. What is, by the way, not actually cheap. This is a really cool thing, then it's really easy to handle. Then I have this probe, and I don't know if you can see that on the probe. Each probe has 2, how you call them?
2 terminals.
2 terminals.
Or probes,
Thank you.
yeah. Tips.
I'm always happy to have somebody who can speak English with me. So now my thing is not holding anymore. Ah, come on. Okay, I have now 2 terminals of 1. One is applying 1 amp, goes to the other, and the other one is a voltmeter. So now we have amps and we have measuring volt. We know current, 1 amp, we measure the result of voltage. So now, Ohm's law, we can calculate.
And that meter does it internally very accurately.
And that, yeah, for that money.
I know my traditional DVOM, I know it puts a small amount of current through a circuit to measure resistance. It applies a small voltage, essentially interprets that as some current flowing through that, and then does the calculation. But that is at a very low voltage level, and they're in a very low current flowing through it. So what you're saying is, by applying 1 amp, that allows us to more accurately identify very small resistance variations that might exist, where we would never detect that with even some of our better quality DVOMs.
You know, and what you do now, you have your cable. Now we have actually a measurement of this cable. You can tell me how long is this cable? How long is it?
Cable's about 2 foot long overall.
Okay, that's like
maybe
80 centimeters. I'm, metric guy. 3 feet is a meter approximately. So when I would measure now from one point to the other, I would expect a measurement of like 0.8 milliohm, a little bit below 1 milliohm. 3 feet should be 1 milliohm. This is an expectation what we have. And this is a guideline for us. Is it much higher, then I know my bonding is not that great. Okay, and I can perform here one measurement.
Show me the accuracy of how this works just on a piece of steel.
Just on a piece of steel.
And I would expect, with a traditional DVOM, if I did this, I'd see 0 ohms.
0 ohms, yeah. Let me go.
Especially if I zeroed my meter out initially.
I pushed that a little bit down, my 2 probes. I have to see, and we have 0.0469 milliohm. Really accurate. Okay, when I'm going now a little bit farther away, what we're expecting a higher result.
It should go up.
Yep. Let's do this. And what we're getting out here, and this is a piece of steel, 0.18 milliohm. So on a distance as you described, I expect around 1 milliohm, what would be a good result. So now, I'm a European have their regulations. In this European regulation, what is pretty cool, that's the reason why I like regulations, and it's also defined what's supposed to be there. And that 1 meter or 3 feet per milliohm is one number in that regulation, and the whole system, every component in that should be under 100 milliohm. So now we have a guideline and we know what is good and what is bad, and that's what I need as a technician to know.
I know I've seen references to this in some of the service information from different vehicle makers, where as things are being reassembled, they'll have you as one final step in that procedure doing this resistance test, this milliohm test, and they'll have specifications typically for the different points that they're having you do their measurements on.
So milliohm meter, in my opinion, a really important tool when I'm working on EVs. Isolation or insulation tester is another important thing to check really, and this is a mega ohm meter. No, too big
Again,
amp or
so how
smaller.
does that become different from, again, my traditional DVOM? I'm measuring resistance.
Yep.
And if I'm checking something, I'm looking to see if there's shorts or, you know, some sort of condition there. Gee, you know, if I see infinite resistance, I think, hey, everything's okay.
Yep.
But is it really okay using a traditional meter versus the test that this applies? So how does this differ?
Okay, the difference is here we're working with a current, 1 amp, as we described. Here we're working with a test voltage. So what we want to do is we are on a 400 volt system here. To really make a test under load, we need minimum a capacity of a tool what can apply 401 volt. This is also like a little guideline. We have to be always 1 volt higher as the system has voltage. So we have here 400 volt, we apply 401. This guy can here, this insulation, you can select between 500 and 1000 volts. So in this case, I would select 500 volts and apply high voltage plus against ground, high voltage minus against ground. To verify, is there any insulation error between my high voltage plus connector and ground. So now we are back on bonding. Remember, when your bonding cable would be not unhooked, I can measure and I would never verify any insulation error.
So if there is a breakdown of insulation someplace that my traditional meter might not read, this is, I want to call it a stress test.
That's
to a certain degree.
One side is a stress test. What requires a good bonding? So everything comes back to bonding. That's the reason I think it's so important to talk about it and really make people aware. Hey, bonding, this is no joke. But these cars are running. We are here in Wisconsin. I'm going out there. There is snow out there. Now
there's chemicals. There's chemicals they use on the roads.
And how is that in 5-10 years? And then when we're getting into contact with these cars, 5 years after an accident, and we have to fix some stuff. That's a huge challenge what our industry is facing, in my opinion.
These are complex topics that ultimately folks that are working on these vehicles need to understand. And you know, I have a very strong belief that if I understand what I'm working with and the potential of what can go wrong, how the vehicles are engineered, this helps me gain comfort, not to be cocky or overly confident, and I don't want to get complacent. You know, that's something that can get you in trouble. So making sure that you have a firm understanding of the topics and the concepts is very, very important.
And I know we didn't point that out, but I think the audience saw that vehicle a little bit on a couple of shots from the behind. This is a huge accident. I learned it's a total loss. And the whole EV system is functional.
It's still intact. It still moves itself around. It's impressive.
It's
impressive. The engineering that went into it, and you know, ultimately the vehicle did its job structurally. It protected the occupants, and the vehicle can be replaced.
Okay. Do you want to more pointing out here? I thought you had a couple of thoughts.
I think there's a few other things that I'd like to cover briefly under the hood. Whenever I think about cooling systems, you know, I know that this particular vehicle has an air-cooled battery, and that there's still a cooling system for the electronics and other components. So, you know, that's something that is a topic of consideration for folks working on these vehicles. I know some of the cooling systems get pretty elaborate, you know, with the different valves and motors and pumps, and especially whenever you start looking at where they liquid cool or some other means cool the high voltage battery. Can you tell us a little bit more about what's going on with some of the cooling circuits and things like that?
Yeah, you said it, water-cooled, air-cooled. There are still also air-cooled batteries, but of course the battery is really important that we hold it constantly on one temperature. Different manufacturers have different temperature levels for a battery, but for the lifetime of the battery, really, really important. And then you say coolant, cooling pump, and that's like, I think, a little bit more our aero field, what we see in the future, that maybe cooling pump is failing or thermostat is not operating, things like that. And that's then like our new, yeah, you know, you don't have a combustion engine anymore. That means our failure source is getting actually down.
Yeah.
And I know when we talked about hybrids or electric vehicle like that, electric vehicle actually so easy, in my opinion, than full codes of failure.
But it's different for a lot of folks. There are some folks that are adapting over and they're working on these vehicles on a regular basis, and it's having the right training, having the right information, service information resources, having the right tools and equipment. You know, it's a big investment in order to be able to fix these vehicles correctly, and that's real important. You know, I think about some of the other components that I'll just mention briefly. You know, chillers and PTC heaters that we've kind of referenced along the way. That may be parts of these systems that take and help manage the heat of the battery and the drive motors and inverters, and even provide cabin heat for the occupants and the air conditioning. Some of these vehicles may even use heat pump systems on the air conditioning systems that bring another aspect to, I'll say, working with all the plumbing under the hood with the air conditioning. The basic concept is still very similar what we're used to on air conditioning systems. You know, high voltage electric pumps are pretty common on the hybrids, as well as absolutely going to be found on the electric vehicles, and real important that we've got the right service procedures in place for those as well.
Okay, so any comments or thoughts after watching that video?
I think I've learned that I need to get a better agent. I think Dirk negotiated better than I did. He's in every one of these videos. He's constantly talking. Yes, I think it's in his contract.
Yeah, it is. And you know what? He's got a lot to say, especially around
my German accent. My German accent.
Yeah, it fits, right?
Is that it? You have to talk twice as long because people don't understand? Is that what that is?
Yeah, possibly.
No, I think that what we just shown were 4 great videos that really help anybody that's watching, help the collision industry really understand the importance of understanding the safety requirements and how to do some of these basic procedures to ensure the vehicle's safe before you start working on the vehicle.
Yeah, absolutely. You know, I have a lot of concerns about the safety and shops' tendency to just fix cars, and they see this as a vehicle just like they see any other. You know, and Bud, I'll let you speak to the courses that we have available around that here in just a second. But a lot of shop owners are quick to say, well, you know, if the gold class requirement doesn't require I take this, I'm going to wait until it does. But I'm going to offer that there's at least a couple of these that, you know, the gold class requirements shouldn't be what makes you have your staff and yourself take these courses. It is absolutely about the safety of the vehicle, even if you are having another outside organization actually do any EV work for you. You need to know a certain amount about these cars when they are in your shop. Bud, you want to talk a little bit about the courses that we offer? Sure.
So we've got several, and some of them are new and releasing here first quarter. But you know, we have things like Introduction to Electric Vehicles and High Voltage Vehicles. It essentially helps you understand how to identify those vehicles and some of the things that everyone needs to know, how they operate. You know, if you have to get in and move the vehicle, how is it different than a typical combustion engine? We've got another course that is high voltage safety, which goes into more detail, similar to that first video we played, but they go into deeper detail and explanation of the things you need to consider for safety. We've got another one that is inspection and handling of high voltage vehicles. So that's about the vehicle that comes in off of a rollback and it's been damaged. What do you need to look for to make sure that that vehicle is safe before you even have somebody go out and hang a key tag on it? You know, how do you know that the vehicle is safe to store inside your shop and it doesn't have to go into a quarantine area, for example, out in your lot somewhere before it can come into the shop? And then we've got another one that is EV damage analysis. You know, so that's around the estimating side of it. That's one that's coming later in the first quarter of 2021. And I think the other course that we've got in development is EV service considerations, and it will walk you through understanding some of those high voltage parts and some of the things you need to think about when you're working on these high voltage vehicles. You know, none of them are intended to replace the manufacturer training if you've got a manufacturer that has certification requirements and things like that. Not intended to replace those. Yeah. It's intended to give the shops enough knowledge to keep them safe when they do have these vehicles arrive in the shop, and to complement that manufacturer training.
Yeah, and I think that's a really good point. And I would certainly encourage shops, if they are going to work on electric vehicles, to really consider getting OEM certifications and training around those specific vehicles, because this isn't something you want to play around with, like some of the things historically that you can figure out. This is not one of those areas at all. So, Dirk, you have any last words about it?
Yeah, let me dive into one subject, and this is insulation measurement. Mm-hmm. And you guys were going exactly in the right direction. Manufacturer related or certified training, they train you really practically how to operate diagnostic tools. And an insulation meter sounds not like a crazy thing. You buy that, it's like a nice little multimeter style of thing, but it's a mega ohm meter. And what it's doing is we applying voltage to the system. And for example, when the vehicle has a voltage of capacity of, let's say, 360 volts, where a lot of European manufacturers running on, and then you have your multimeter what can apply 500 volts. You put 500 volts into the system and you check if there's any insulation error. But what you do is you charge the capacitor. And in this time you charge the capacitor, the vehicle is charged with 500 volts. So I was so stupid in my career on a dummy what we did, and we worked with inverters and did some testing, and I charged a resistor and capacitor in those systems, and that was not a live thing. It was only, as I said, the inverter, and I touched the lead. Bam! I got one shot. That shot was so strong that I don't forget it, mm-hmm. And you're not dying. Then you put 500 volts with a multimeter on. It's not that of a big current, but it hurts. And yeah, that's also the small things what you can make wrong only to operate even an insulation meter. And that's what I wanted to point out. You have really to go through a training class. You have to learn practically how you're doing things, and you have to be aware of the risk. In this case, is maybe not the risk you will die, but definitely my hands were flying around. And when Jeff Peavy would stay next to me, possibly his glasses would be flying around the workshop.
Hey, if the worst thing that happens is it knocks my glasses off, I would be happy. You're very fortunate that was all that happened. But that's a good example of the concerns. And I want to tell the folks that are listening to this roundtable, again, just a very casual conversation around some work that we did recently that really just stood out to us, that maybe it would be for us to have some conversation around it. And I think the industry needs to get used to us having more conversations like this and sharing things that we're working on. Our technical operations at iCar is growing tremendously. Our work with the car manufacturers are growing as well. And also that we can provide information and training to the collision repairers to help them be able to do a complete, safe, and quality repair, and also keep their technicians and estimators safe. So, Bud, Dirk, thank you for taking the time to be involved in this. And both of you, even though, Bud, you wasn't in those videos, I know you had a big part in those videos behind the scenes. And we're going to share more of what we do technically within iCar, so that the industry can have an appreciation for the world-class technicians and the operation that we have at iCar that puts it all together. So I wanted to, again, thank both of you for being here and us hanging out and talking. Thank you.
Anytime.
Thank you.
Thanks, guys.